welcome back to another episode of Likeable Science here on Think Tech Hawaii, where each week we explore more things to like about science. I'm your host, Ethan Allen, and today we're going to discuss another fascinating new innovation of filtering water. Filtering water is a really critical technology for millions, hundreds of millions of people around the globe who lack access to clean water. Today, joining us via Skype is Dr. Terry Dankovich, the founder of Folio Water. Terry, it's great to have you on the show. Welcome.
Hi, it's good to be here.
Excellent. Thanks for joining us tonight. Tonight where you are, today where we are here. So Terry, let's just jump right on into this and tell us a little bit about how you got involved with this business of water filtration.
Well, the project started for me basically around 10 years ago. I was a PhD student at McGill University. I was in the Department of Chemistry, and my project was to add an antimicrobial chemical to paper in the application of a water filter, which is pretty broad. I could have gone many directions, but I started to kind of go down this point of use for developing countries route pretty quickly when I saw that there was like such a huge need of people who didn't have access to clean drinking water. Yeah,
exactly. There's a real, I don't want to say market out there, but there's a real need for this in the third world, in developing nations where people sometimes have to either walk great distances to get water, and basically you don't just have taps where you can turn on and get your water right away. I see behind you, you actually got some of your apparatus here, and I think it's a real nice demonstration here. Well, maybe while you set it up, I'll just say a few words. It's one of the key issues in a lot of places to have a very simple technology, and you can see, our audience can see Terry is taking this piece of essentially a coffee filter looking like thing, folding it up very simply into a classic coffee cone shape, putting it into what looks like actually a coffee filter type apparatus, although it's slightly different. But in that this actually attaches, it has threaded ends on both ends, so it attaches to bottles. So you have a bottle of dirty water and a bottle of nothing in it that is clean, that you want to put your clean water in.
Yeah, so this is the...
Right. So she puts this is presumably the muddy water or dirty water.
Oh, no. Get it screwed on nice and tight.
Okay, and then, let's see. Then, yeah, now she puts the other bottle on top, the empty bottle on the bottom, and then?
And this is the exciting part.
Right.
Where you flip it.
And bit by bit, that water now is going to filter through, and the substance in your filter that's doing the antimicrobial is, of course, nanoparticles of silver. Am I not correct?
Yeah, that's correct.
And as I understand it, and please, you certainly know much more about this than I, silver is quite toxic to essentially a wide array, virtually all microbes, but not particularly toxic at all to people, at least at low levels.
Yeah, let me just make sure this is stable. Okay. Looks like it's pretty good.
Okay.
All right, sorry. I don't want to like have that tilt in the background.
Right.
Hopefully it'll be pretty stable. So can you please repeat your question?
So I was just saying this is, it's impregnated with silver nanoparticles, and the mechanism by which the silver is actually toxic to the microbes isn't terribly well understood as I've read.
Yeah, from what I understand, it's not. It hasn't been figured out the specific mechanism. There has been many observations that have been made by scientists, and some of these include disruption of the membrane structure to the cells. So, like, it looks like there's holes that form. Sorry, this is actually forming a little bit of a pressure seal tonight, so. There, that's a better flow. Anyway, so once the cells have little, so the contents start to leak out, and the silver can bind irreversibly to DNA and proteins because of the strong linkages between sulfur groups on them and silver itself. That forms a very insoluble compound that's well known in, silver chemistry.
Okay, okay. And so you sort of, in your graduate work, you came up with this idea of putting the silver nanoparticles into the paper. And then I suspect you had to spend some significant amount of time figuring out just how to get the silver in the right concentration and the right way into the paper.
Yeah, so a lot of the project during my PhD was looking at not just one, but several different methods to add silver nanoparticles to paper. Like you can think of many different ways, but so a chemist's job is to kind of figure out how many different ways, which ways work the best, which ways don't work so good. So I started with, like, for example, a compound that was very reactive, that had some toxic byproducts that worked really well, but I wasn't sure if that was good for the long run. So I started to work with non-toxic materials to make the nanoparticles, and that's what we use today. But yeah, a lot of the PhD work was figuring out some of the basic synthesis methods, and then proof of concept in the lab, which means you test with lab-grown bacteria to see if they, you hit the right concentrations of silver. So it's not too much silver in like the drinking water afterwards. It's okay to have a little bit of silver in,
right?
But if you have too much, that can be not good for people.
Right.
So it's like a fine balance you've got to work with there.
Yeah, when I was talking with your one of your former professors, Jim Smith, he said the same thing with his Maddie drops. He had to play around with the concentrations so that they would come out just right in the water and be enough to be quite lethal to all microbes, but still only about 1/10 of the level that the EPA considers safe for human consumption.
Yeah.
Yeah. So you started doing these, and then at some stage you must have begun to realize that this was going to be a worthwhile product, an actual, rather than just being graduate work, right?
Yeah. So basically, I graduated about almost 5 years ago now for my PhD, and then you mentioned Jim Smith. He was my first postdoc advisor when I was a postdoctorate researcher at the University of Virginia, and that gave me an opportunity to work with, someone who obviously knew a lot about working in developing countries. As at that point, Jim had been to, I believe, Guatemala and South Africa. I'm not sure what other ones, but definitely those two. And he had a lot of experience with taking innovative technologies to the field, as you're well familiar with. And one of the things I did in that postdoc was going to South Africa and seeing really what life could be like in some of these rural, poor areas, and seeing how well this filter worked in that setting with like water sources that people did drink from without any sort of purification. And so that was, obviously very eye-opening, and basically I saw, oh wow, this actually could be effective, but I need to kind of, alter the design and look at what makes sense for what people would use like in their household. And this was not the design that we had back then. This is a modified, updated version. The version back then was a little like lab, much smaller. It was like more what you use to characterize something in a lab setting. So,
yes, indeed. So, and then as you've developed this, you also, of course, face this problem, and we were discussing this the other day, about sort of scaling up production, right? Because these paper filters each one will filter so much water, but at some point you basically, it's done, it's got a relatively limited life, right?
It is paper. Sure.
Right. And so you're trying to produce, ultimately, you produce it in these booklets, and here's a picture I guess we have on now of your current production machines rolling out rather impressive quantities of the folio paper. So at each stage, I'm sure as you're sort of doing this differently, the way in which you get the paper impregnated with the silver must vary. You must have to sort of reconfigure your whole process sort of at each scale-up step. Has that been a challenge?
Well, yeah, of course, but it's something that luckily the technology to start with worked out pretty well. That each scale-up hasn't been as bad as, I don't know, it hasn't been something we couldn't do, I guess is the best way to put it. So the scale-up first started from me going from making tiny little squares that are yay big. It's something that you could cook in a, you know, a lab oven or prepare in lab equipment, which is usually small scale, up to something that I did actually in a commercial kitchen, in the church kitchen, which used big bacon trays size of paper. And now it's just on a paper machine. So this is like our bound pack of paper, it's just shrink wrapped. But it's just I don't have any rolls with me, but it's just like a big roll of paper that's this color. And this stuff could be made much, much quicker now. We've made way more paper this past year than, you know, any year before that, for example, like in the tons scale, not in the, I guess, pounds, grams. So, you know, orders of magnitude bigger. But yeah, the scale up there, the process has changed a little as it does, but you know, it still was something that even the first time that we tried it on the paper machine, we still had something that we're like, hey, that looks like it's not so bad. And, you know, it's something we could work with. And now it's even better as we've done this a few times using industrial paper machine equipment.
Excellent, excellent. So are you, I know there's a bunch of interesting stuff going on. There's lots of different approaches now to this idea of filtering and purifying water. There's this wonderful, these Folia filters that you've got. There's Jim Smith's thing, the Matty drops, which of course are not a filter in any sense. They will leave murky water murky, but they will kill off the microbes, as yours does, but yours filters it as well. You deal with sort of 2 liter quantities at a time in yours. I was talking with a young gentleman from University of Southern California last week who and his colleagues have developed a little sort of cylindrical sort of filter that can run 380 gallons a day or something through it.
Yeah.
And so, yeah, there's all these different things that I think it goes to show there's not a sort of one-size-fits-all solution here. There are different people are going to need different amounts of drinking water at different times for different needs, right?
Yeah, and different cultures too.
Right. Sure.
Yeah.
And it matters if you're on your own or if it's a whole family. Are you sort of in one stable spot, or are you having to carry the water with you? All these things will come into play as to what's great. And what's really impressive, I think, is these technologies are very appropriate. That is, all of them, the ones I'm seeing now are these quite low-tech sorts of things where they may be based on very high-tech nanotechnology, but they're very simple to use for the end user. And that's really critical, because things like reverse osmosis is just way too complicated for a lot of the settings where people are most in need of the water.
I can say from my own experiences that I've worked with now a couple of industrial designers, and there's it's not industrial designers don't always go into this sort of market, just as scientists don't always go into this sort of, you know, like this is a kind of well, for lack of a better term, a low profit making endeavor for the most part. It's people do it because they're passionate about helping others. But I've met many industrial designers that have been like, oh, I don't want to make just the latest flat screen TV or, you know, the newest chair or whatever, and have been interested in solving like this sort of problem. And this design came out of, it wasn't exactly what we had from the industrial designers, but it was influenced by a lot of their work. And it combined with engineering designers too. Like, so, you know, this is not just me who made this. I'm not going to take credit for that, but it's taken a team to come up with this idea. And this is actually our first version. We have a new and improved version that's going to be done in a couple of months.
Excellent. We're going to have to jump out for a short break here. Dr. Terry Denkovich from Folio Water, CEO, founder of Folio Water, is on via Skype with us today on ThinkTech Hawaii. I'm your host, Ethan Allen, and we'll be right back.
Aloha, I'm Kaui Lucas, host of Hawaii is My Mainland every Friday here on Think Tech Hawaii. I also have a blog of the same name at kauilucas.com where you can see all of my past shows. Join me this Friday and every Friday at 3 p.m. Aloha.
Okay, I'm here with Brett Obergard of the faculty of the School of Journalism in the Department of Communications at UH Manoa. We've had a number of shows. We have a movable feast going on, and we talk about journalism, we talk about language, we talk about communication in general, and we talk about the effect of that on the country and on individual people. Brett, it's so good to be able to discuss this with you in our movable feast.
Oh, it's my pleasure. This is a great opportunity.
You'll have to come back again and again, okay, deal?
That's the deal.
Brett Obergard. I'm Jay Fidel. We care about everything. Thanks.
And you're back here with me, Ethan Allen, your host on Likeable Science, here on a Friday afternoon on Think Tech Hawaii. Joining me via Skype today is Dr. Terry Dankovich, and we're talking about her new folio water filters that are silver-impregnated paper filters that kill off the microbes, as well as sort of physically restraining sediment and all going on through. Invaluable tools for the people who don't have access to clean, processed water. Before I get back into the conversation, though, actually thinking about the various different technologies that are being used now to filter water and the various different approaches that people take reminded me of a story I heard years ago about sort of multiple approaches. These scientists were training chimpanzees and trying to study the intelligence of chimpanzees. And they set up a problem for this one chimp. They put the chimp in a room, and hanging from the center of the ceiling was a bunch of bananas the chimp wanted. And in the room was a stepladder set up and a long pole. And they wanted to see whether the chimp would pick up the pole to knock the bananas off or would move the ladder over to climb up and get the bananas. And the scientist walked on in with the chimp, and the chimp looked at the pole, looked at the stepladder, reached up, took the scientist by the hand, walked the scientist out in the middle of the room, and climbed up on the scientist and took the bananas down. And I just sort of thought, in a sense, this is the same. It's a sort of parallel situation here, right? There are many ways often to get to the same goal, and some creative thinking will sometimes get you there really fast. Anyhow, sorry, a little off the side there, but so Terry, tell me this. What do these filters filter out, and what don't they filter out?
All right, so these filters, as we've talked about before, contain silver nanoparticles, which are lethal for lots of different types of bacteria and also some types of viruses. I personally haven't worked with viruses, but I've seen in the literature reports of a few types of viruses that silver can kill or inactivate. It also doesn't necessarily kill protozoans, but it has a pore size small enough to screen them out and get them stuck on the filters so they can't pass them through them. And so we've tailored it for the microbiology. It can also remove dirt particles, as mentioned before. We have not tailored it to remove heavy metals or pesticides, so there might be some physical absorption to the paper, being that there is some absorption that will happen, but it doesn't have any extra chemicals to really focus in on those heavy metals. So no, it doesn't remove lead, if you were wondering.
Right, no, the one simple paper filter can't do everything, but it does amazing things. And about how? So you've been producing these now for, you said, for several years, and how many do you think you've probably produced at this point, distributed?
Well, so far, I was doing the numbers because we're just starting to get track of these things as a company, because we've just started to distribute over the past few months. And basically, we're at about 1,500 of the books format, and the books, dependent upon where we have distributed them, have had between 10 and 26 filters. Mm-hmm. So probably about 20,000 filters.
Wow.
Order of magnitude.
That's got to feel good. I mean, you've helped probably 20,000 different people then avoid gastrointestinal illnesses and serious.
Well, it's not necessarily one-to-one. It's it's a pack of filters, so it's probably closer to the 1,500 for a number of people, or maybe a little bit more in 2000 or so.
Yeah, no, that's still, it makes a real difference in people's lives. I've had colleagues get gastrointestinal illnesses traveling in the islands here, and it's no fun at all. And so what do you produce any educational materials with these, or you just sort of figure that people are going to know how to use them?
No, we some people understand very intuitively upon seeing the demo. They're like, yeah, that's easy. But we don't want people to be confused once we're not there. So this is the inside of our packet. It's basically just a picture telling you how to do it.
Excellent.
And then down here, let me fold it over. You can see this is just how to fold into a cone, and then kind of guidance on when to change the filter and when it's okay to use. So people will feel like we do also recommend, based on 100 liters, but most people don't remember how many liters they filtered, so that's not necessarily the best guidance. And on the back right now, we just have a cartoon that one of our friends made that explains the science behind it. It does have words in English, but eventually we'll get that in foreign languages as well. But it's mostly a cartoon. But this is like our first product that we're selling. This is the third prototype. We've had, as a lot of people have heard on the news, the Drink Level book version that I worked with, a nonprofit called Water is Life, a couple of years ago. And excuse me, that was written in English and Swahili, and I can show that to the camera too. So you can kind of see that. And this one, unfortunately, the cover is actually very expensive to make, and the filter sizes aren't optimal. They're kind of small. So we've moved beyond that. It's more of a first version to the newer one. And we're still learning how to best print on the paper at mass production scales. So maybe in a few months we'll get that sorted too. So right now we're just going to print on the packaging, and maybe in the future we'll get the mass production of the print-in sorted as well.
And so you have this, you've got your website up where you sell the packets and all. What are your plans? I mean, how do you want to scale this up and begin to really distribute these more broadly?
Yeah.
How do you see yourself going about that?
So right now we've been working with a lot of smaller nonprofits and church groups. Like, for example, we've worked with a medical clinic that is run by a doctor here in Pittsburgh, and the medical clinic's in Honduras, in a mountainous area. And we've also worked with Rotary groups that often go to various countries and do water projects. And that's like basically to start to get the word out. But our goal is to move up to local distributors in country that can distribute to like either pharmacies, grocery stores, corner stores, and get it so it's a sustainable supply chain, because we're recommending to change the filter. Well, it depends on how many people are using it, but every week to every couple of weeks. And that's, you can buy the packet, but if you are using it a lot, you're going to want to be able to get it locally, not just through our website or through somebody that comes from the U.S. to, whatever country. Excuse me. One of the pushes that we're trying to make right now is into like the Dominican Republic and Haiti, and there's problems in both countries. I mean, the aftermath of Hurricane Matthew is still a problem that hasn't received as much attention since October, really, but there's still like hundreds of thousands of people who lost everything because of that hurricane, and basic necessities are really what you need first. So that's one of our first steps for this year, and so I like really wanted to stress that one. And we have someone that's really focusing on that area in our company as well.
Yeah, it's sometimes these areas get very hard hit. We've just had one of the islands that I work on got hit by a water spout, which is very unusual, and it just went over it and really destroyed ripped a path of destruction across the island. Fortunately, it wasn't very wide, but anything that was in its path was pretty well wiped out. And so these people lost rainwater catchment systems and roofs off their houses and all that kind of stuff. So how will you know when you have succeeded in this business?
Well, I think in the short run, we'll know when we've sold a bunch of products that if people use them right, they're going to get clean water. If we start to look at it more as a business, we'll have to look at it as a certain amount of growth per year and, you know, the whole return on investment and so on and so forth, the business metrics. But, you know, our background is more from the heart of the social enterprise side of things more than the for-profit, just pure business. So we're going to look at things, how we make impact on people's lives. And that's hopefully more than just clean water, but better health, less disease. And it's a little bit harder to measure, but, you know, we're hoping to work with partners in the university to, like public health doctors and people like that to help understand some of those impacts better.
Sure. One of the things we're doing to look at this issue is looking at school attendance rates and seeing if when they get clean water sources, does school absenteeism drop? Because basically, if fewer kids are sick for fewer days, you should see a nice increase in school attendance, and that's and again, that's sort of a win-win-win, right? The kids are healthier, they're spending more time in school, they're learning more, so it's to everyone's advantage.
And then their parents also don't have to stay at home with them too, so they can also earn more money with their jobs too.
Exactly. So, what advice would you give to aspiring scientists who want to make an impact in the world? Just very briefly.
Well, I think I got to where I was because I didn't give up. Like, there's so many points along the way that I could have chose to do something else that would have been maybe, you know, paid better. It would have been, I don't want to have to work as much. I feel like I work a lot of hours, a lot of the days. But I like what I do. So that's, it doesn't, you know, it's not a negative one.
Excellent.
So I think you have to believe in it.
Well, thank you so much, Sherry. I've really enjoyed talking with you. Learned a lot, as I always do on this show.